Hello, in this tutorial I'm going to show you how you can make contested health. Now what I mean by that is a portion of your health you have after taking damage that can be recovered by attacking. To be honest, I stole the name from Space Marine 2, but this mechanic also famously exists in Bloodborne. It was a little less popular in Elden Ring. I'm pretty sure it exists in Remnant, though I haven't played that. And I know it exists in a way in Lords of the Fallen. But they all work slightly differently. The Space Marine 2 version is a portion of your health immediately after taking damage becomes your recoverable health, which slowly ticks away. Taking more damage doesn't tick away at the take any damage from the contested health pool, whereas the ones in the most of these Souls-like games are going to update alongside your regular health. So taking damage to your health also takes damage to the contested health. Now, before we begin, there's a couple of things you should know. There is this BP enemy test, which basically just plays an attack animation on loop. Another thing is we need to go into AC weapon trace, and here when we apply damage, I have added a damage amount to this blueprint interface and a on damage dealt. So I like using literal floats when I'm prototyping things because you don't actually have to make any variables, but you can still set it from one central place to then update both of these values at the same time. But before we can make contested health, we need some actual health. So let's go ahead and make a new blueprint class of type actor component, call this AC_health. Open this up and add a bunch of variables. The first variable being current health, which is a float. Then there is max health. Then there is, I'm going to call this CH underscore. CH stands for contested health, but having to write out contested health on each of my variables will make their names very long. So I'm going to keep CH amount. Then there is CH_decay delay, CH_delay per second, CH_return percentage, which is when we deal damage, how much of that damage is converted into health that is then recovered, and CH take percentage. So when we take damage, how much of that damage can we actually recover? Let's also set some default variables. Current health will be 500. Max health will be 500. CH amount is going to remain at 0. The decay delay will be 3 seconds. The decay per second is going to be 6. My return percentage is 0.5, so that's 50%, and my take percentage 0.25, so that's 25%. Compile and save this, and one more thing, class defaults will have start with tick enabled set to false. Now what I'm also going to do is in class settings, go to implemented interfaces, and add BPI weapon trace, because this has the apply damage function. So now we no longer apply damage to the actor, we instead apply it to the component on the actor. So in AC weapon trace, here drag off target and say get component by class. And we get the health component and use this to apply damage. You can put this on any actor and they will then have health. Now if you have health, you can probably take damage. So it would make sense to have the damage logic be applied to our health component instead of our character directly. So when we apply our damage, I'm going to set the current health to the what we have currently minus the damage amount. And I also need to clamp this between max health as the maximum to prevent healing when we take negative damage, and the minimum is 0. and we set this as our current health. Now we can't actually see our current health because we are missing a widget. Now I could just print it, but that's boring. I'm going to add a widget in my health defense folder. So let's make a new widget blueprint. Call this WBP_health bar. Open this up. I'm going to add an overlay as well as a border. I will make the border fill completely, set the desired size to desired. Oh, and I can wrap the overlay with a size box. I will set the width to 400 and the height to, let's say, 20, like this. And I will make the brush color a sort of dark brown, like this. Inside of this, I'm going to add a progress bar. I'm going to set all of the padding to 2, and I will set the background to very dark gray. And the fill color, I will make this red. I will rename the progress bar to PB for progress bar _ health. Compile and save this. And then we need to add this to our HUD. I notice we don't actually have a HUD widget yet, so let's make that first. Create a widget blueprint, user interface WBP_HUD. In here, I'm going to add a canvas panel. And then our health bar. Make sure to set size to contents to true. And I'm going to set the translation to 50 and 65 to add it right here in the corner. So then let's add this to our character. On begin play, I'm going to create widget. The widget class being WBP HUD. And the point of the HUD is that you add everything else in there as well. So if you have a mana bar, like a crosshair, your equipment, everything else should be added in the HUD. And then you have a central place from which you can access all of these widgets. So I'm going to promote this to a variable, call it HUD. And add to viewport. So now we can see our health, except there is no health currently being displayed because we haven't updated the widget yet. Now what I see a lot of people do is they will tell you to bind the percentage here to your player's health. But honestly, I think this is a terrible idea because this will constantly, every single frame, it will try to find your health and then calculate the percentage. But you should know when your player takes damage. And if you know when they take damage, you know when their health changes. Thus, you know when to change the widget value. So if you just change the widget value whenever the value it is supposed to read changes, you won't ever have to bind it every frame. So that's why I think this is a terrible idea to create a binding to it. Instead, because we know in AC health when we take damage, we are going to update our widget then and there. So let me make a new function, call this update widgets. Widgets plural, because we are also going to add a contested health bar later on. But of course we don't yet have a reference to our widget. So I am going to create a new variable, call this widget ref. This will be WBP HUD. And then in our third person character, we can get our, oh, whoops, I forgot to add it again. Typical AC health, and add this, then get it and set HUD, or what is it, widgets ref, to our HUD. And then we can update widgets. Now, before I do any of this, I'm going to add a short delay here. let's say 0.1 second. Because right now there isn't much to our character, but as your game grows, you will be adding more and more components and systems and everything that needs to initialize. So in order to make sure everything has properly initialized, I add a little delay here, so as to give the health a bit of time to actually initiate, so we can properly set variables and functions from it. So now with our new widget reference, we can say get health bar and say get pb underscore health. So this is the actual progress bar. We say sets %, and the percentage will be our current health divided by max health. So this function will update the entire widget by setting its percentage. So let's go to event apply damage and set or call update widgets. So now when we take damage, we immediately update our widget. So let's test this one out. I take damage, and indeed my widget gets updated. You can see me taking damage. So now that we have a basic health and damage system set up, honestly it's not much to write home about, but it works for now, we can add our contested health. So in order to know what our contested health should be, we should know how much damage we have taken. And we can do this from event begin play. I'm once again going to add a short delay. Let's say once again 1 second, 0.1 second. I'm going to say get owner, and then say get components by class. Be sure it's components, the plural, because we can have the component we are using is AC weapon trace, and we can have multiple of these in our characters. So then for each loop, drag out and press F to create one of these, and on the array, and for each of these components that we have, we should say bind event to on damage dealt. This here we say create event and create a matching function. This function being not AC health autogen func, we need it to be calculate contested health. So I'm going to show you two different ways to calculate contested health. The first one I'm going to show you is based on most of the Souls-likes that I've seen, where your damage is immediately converted into contested health, so you don't actually have a separate health bar. The other one is the separate health bar, which is the one like Space Marine 2, where your damage taken does not affect your current contested health. So let's find a way to differentiate between the two by adding a branch and a new variable, which is ch underscore retriggerable algorithm type. Bit of a long name, but this is just a boolean. I can add this here. So the retriggerable algorithm type is the one that we use for most Souls-likes, as it is triggering every single time that we take damage. So for this one, I need to set the contested health amount to, let me see, we get the damage amount, we multiply this by the take percentage. So the damage taken gets multiplied by a take percentage, and this percentage becomes recoverable. So we add this to current health, because it is on top of current health. And we clamp this, oops, not clamp axis, clamp float. The minimum is 0 and the maximum is max health, because we do not want our contested health to go above our maximum health. And this just becomes the ch amount. I'm going to move this all up, so it's not in the way of our next algorithm, which is slightly more complex. We still just set the ch amount So if you want to copy Space Marine 2 exactly, then you can just set your CH amount to the current health plus the damage amount, I think. So current health has already been lowered by the taking damage. So adding the damage taken to current health will basically set this back to what our health used to be. So what our health used to be becomes what we have as our CH amount. But I like to personally add a little more challenge. So if this is greater or equal to max health, then select float. We set our CH amount to the max health. So basically, if we were in fact at maximum health, then we don't change a thing. We just have our max health as recoverable health, so we can recover up to our maximum health again. Or I could have damage taken multiplied by the by the take percentage, and remove that from our current CH amount. So every time we take damage, our CH amount remains decently high, but it goes a little bit farther down. So taking damage once will have the CH at your full health, but taking damage again removes a small portion of that additionally. Now we should clamp this. Clamp float. Between current health, we do not want our CH. We do not want our contested health to be lower than our current health, and we do not want it to be higher than our max health. So this goes into the B. So the default value for now is going to be true, so that I can show off the first algorithm that we have, and then I will be showing the second one after that, so you can get a feel for how they work. But of course we can't yet see it, so in WBP health bar I'm going to duplicate. I have to move PB health into the overlay and then set the padding to 2. It's already at 2 because a border can only have one child. So this will be PB underscore contested health. This should be underneath PB health. So then PB health is going to have its background as none. And then the contested health will have a fill color of white. Now if I mess with this percentage, you can see that this has added a white bar underneath, and that represents our contested health. So of course, now we have edited the values for our contested health, we need to set our widgets again. So we once again update our widgets. So when we update our widgets, I need to get my PB contested health and also set percent. That percentage being CH amount divided by max health. And one last thing before we can actually see our contested health is that I should set contested health amount to current health on begin play, so that we start with the exact same amount of contested health as what is our current. So let's try this one out. And you can see that a portion of my health is recoverable, and each time I take damage, well, it's not exactly doing what I need it to. Oh, of course, on event apply damage, which is when we take damage, we need to calculate contested health. So the amount is the damage amount that I took, which makes me realize this is completely incorrect. We do not calculate our contested health when we deal damage, we calculate it when we take damage. So this will have nothing for now. This should be to regain health, which I will cover in just a moment. For now, let's see this contested health in action. You can see me taking damage, and a portion of that becomes recoverable. And because this guy is doing the same amount of damage each time, you will see the same amount of recoverable health each time. If I were to say in the weapon trace, make literal floats and say random in range, deal anywhere between, let's say, 35 to 75 damage. Try this again. If I now take damage, you can see that my recoverable health is either bigger or smaller, depending on how much damage I took. See, that was a little one, and this was a bigger one. Now for the other kind of algorithm, which is more like Space Marine 2, you see my health is at maximum, or was at maximum, so it stayed at that point. And now the contested health is slowly taking damage as I do, so I can no longer recover it fully after taking damage a second time. So I'm going to rename this to damage taken, and instead of binding calculate contested health, I am going to create a matching event and call this return contested health. Call this damage dealt. Oh, it says dealt. Here I am going to set my current health based off of contested health. So we have the damage dealt. We multiply this by the return percentage instead of the take percentage this time. We add this to our current health, and of course we clamp this between current health so we don't go any lower than our current health, and our max health so we don't go higher than maximum. And this becomes the new current health. And of course, because we now set current health, we say update widgets. Now, in the update widgets, I just realized our enemy is also going to call this, because he deals damage and therefore can recover contested health. However, he does not have a widget currently, and he definitely does not have our HUD. So instead of just getting widget ref, I'm going to say get or convert to validated get. If my HUD is valid, then I am going to get the progress bars from it. If not, then we don't update any widgets. So once again, I take damage, and now if I damage my enemy, I can recover this health. If my contested health is lower than my maximum health, then if I now deal enough damage, you can see that I cannot recover health beyond my... Oh, I can. Whoops, I made a mistake. I can in fact recover more than my contested health because we clamp it to max health and not to contested health. So if I now clamp this, let's compile, take some damage, take some more damage, and deal some damage. Now as you can see, I cannot regenerate more health than what my contested health allows. So then, if you've played any of these games, you may know that there is a timer before the decay begins. So then you need to be quick enough in order to recover all of your contested health, or you will lose some health regardless. So this is why we made these decay delay and decay per second variables, so that when we calculate our contested health, we are immediately going to start the decay of our health. So let's make a custom event, call this begin ch decay, and here we once again check for the retriggerable algorithm type. If we are using the retriggerable algorithm, then we just say set timer by event and use an initial start delay of ch decay delay. If we do not, then let me promote this to decay timer. Then we check if the timer already exists. Does timer exist by handle? If it exists, then we do not apply it again because we do not have the retriggerable type. So if it exists, then we do nothing. If false, then we trigger it again. Or we trigger it for the first time, I should say. The event will be custom event, which is ch_decay tick. Now it says tick, which is because this should be looping, and the time, I'm once again going to say literal float. And let's say 0.2, so every 0.2 seconds this will tick. So what do we do each tick? Well, we need to set the ch amount, which is going to decay, so we get the decay delay per second. We multiply this by our time. So this is another reason to use literal floats in this case, because then you have the timer that goes at the exact same rate as what we multiply our decay delay per second with. Otherwise you would have to make sure these two are always the same, which would be very annoying. So just use one central value. So then we get ch amount minus the decay delay of this tick. And of course, before we set this, we have to clamp this between current health. We do not want our contested health to go lower than what we currently have, and our ch amount that we already have, so it doesn't go upwards of what we... So it doesn't go upwards at all, it only ever goes down. And of course, because we now set something visible in a widget, we have to call update widgets. Now then, the problem is this is going to keep ticking on forever, which is really annoying, because that means we won't be properly utilizing the retriggerable algorithm types, and it's also just better for performance to disable a timer when you no longer need it. So if contested health amount is equal to current health, either because contested health has completely faded or because our current health has been regenerated to the point that ch amount and current health are the same. So as long as ch amount is less equal to current health, then we set our ch amount to the same thing as our current health, so it's never actually going to be any lower. And then we clear and validate this timer. So we have our timer properly set up, so now when we calculate contested health, we not only update our widgets, but we also say begin ch decay. So if I now take damage, you can see my contested health appears, and it has now started to decay. And this is the version without the retriggerable delay, so you can see it decaying constantly. If I switch to the retriggerable version, then when I take damage, you won't see it decay at all until at some point I take no damage, I wait for a moment, and now you can see it decay. And now it's not decaying because I just took damage, and now it's decaying again. So I've always found this an interesting mechanic, as you can tempt your players into being aggressive, perhaps more aggressive than they would normally be, driving up desperation, especially when the player is at low health. And I've always considered it a fun mechanic, especially in action games. So I hope you found this tutorial helpful in making your own version, and if you have any questions, feel free to leave a comment and I will do my best to help. Anyways, that'll be all from me for today, and good luck!